Okay, let's review over PV diagrams and make sure we understand everything you need to know about PV diagrams. That's a bell. First of all, a few terms we need to make sure we know. Isochoric. Isochoric means no change in volume, no delta V. Key thing about no delta V is that means no work. So understand that since work is equal to P delta V. Isobaric means no pressure change, no delta P. That would be a straight line on a PV diagram. Straight line where the pressure change is the same. Isochoric would also be a straight line on the thing in which the volume doesn't change. Captain Obvious here. Isothermal means no delta T. No delta T on a PV diagram. If this is P and this is V, isothermal is going to be a curve like that. It's essentially Boyle's law. P1 V1 equals P2 V2. If you had no volume change, would be like that. So that's an isochoric line. And then if I have no pressure change, isobaric line means that. So you have that. Okay. Mucho importo equaciones. Sorry, bad Spanglish. First of all, there are really three equations that are going to govern, five equations that are really going to govern everything that you're going to do with PV diagrams. First of all, PIV-NERT. PIV-NERT is incredibly important if you need to find out one corner temperature value. You're generally going to be given the number of moles, which is N. R you know is a constant. P and V obviously will be on the diagram, so you can use PIV-NERT to find one corner of temperature value. So again, you know how to use that. When conditions change, so in other words, I'm going to use PIV-NERT whenever I'm looking for just a single set of conditions. I have pressure, I have volume, I'm looking for temperature. Now, when one or more quantities change, then I'm going to use pole vaulting over trees and simply realize you can only have one unknown. Now, generally, one of those things is going to stay the same in the equation. They'll either tell you it's an isothermal case or an isochoric case or an isobaric case, which means one of those things disappear. And then ultimately, they're governed by this equation here. Delta U is equal to Q plus W, and that should be a delta. Delta U is equal to Q plus W. So in other words, when I add internal energy to a substance, it can come from adding heat or it can come from doing work. So that. Now, the other ones that are important, W is equal to negative P delta V. That's how I calculate work in a pressure volume situation. And then the underrated one, delta U is equal to 3/2 NR delta T. That one's important because it shows you that delta U is directly related to the temperature change, and that will save you some points and make you happy, make you smart. Okay, let's look at a sample problem here, and I have a PV process put on a diagram. I'm going to tell you that N is equal to 1 mole, and you have a variety of things. This is a standard type of PV diagrams. Now, let's take a look in words and what happens in this first. We start at point A, so we're starting at point A. That's our initial point. And what's going to happen now is I'm going to compress A. I'm lowering the pressure in point A, so I'm causing the pressure to go low, but I'm keeping the volume the same. So therefore, the temperature has to go down, obviously. Remember, the highest temperatures are up here. The higher you get over here, the higher the temperatures are. So from this part, what I'm doing is I'm decreasing the pressure, but keeping the volume the same. That would be isochoric because the volume's not changing. There's no work being done during this interval. Now, from B to C, I'm allowing it to expand from 1 times 10 to the negative 3rd meters to 4 times 10 to the negative 3rd meters. So what I'm having now is the gas is expanding during this time. Work is being done, P delta V. And since it's expanding from the gas's point of view, the gas is giving up energy. So from the gas's point of view, it's negative. And then the last part from C to A is an isothermal curve. Isothermally, I'm going back from C to A. Delta U for the whole sequence is 0. So now the first thing in order to really get into serious math with this is I'm going to have to find the temperature at point A. PivNerd. So now, PA, excuse me, I need something to write with. PA times VA is equal to N times R times TA. So divide both sides by N and R. That disappears. PA is 4 times 10 to the 5th newtons per meter squared. Remember, that's what a Pascal is. Times the volume of A, which is 1 times 10 to the negative 3rd meters cubed. That's actually a liter. N is 1 mole. And R is 8.31. And then 8.31 is really just to get the units to work out. What I have is moles times joules divided by kelvins. I think that's right. If it's not, you can check it. And now you go through and do the math with it to come up with what it is. Plug it into your calculator, and you're going to get a value. So, and that's equal to 12 degrees Kelvin when I do it. So that's my temperature at point A. Now the next thing I want to do is calculate the temperature at point B. So let's take a look at that. There's two ways to do the temperature at point B. You could use PivNerd again, and you can be completely comfortable with that if you want. You can also say PA VA over TA is equal to PB VB over TB. The nice thing about that is your volume during this is not changing, so the volumes disappear. So the pressure at A is 4 times 10 to the positive 5th, divided by TA, which was 12K. That's equal to 1 times 10 to the positive 5. I don't know why I want to make that negative. Divided by TB. So therefore TB, I have 4 over 12, which is the same as 1 over 3. So TB is 3 Kelvin. Boy, I picked awful low numbers for this. So again, but you can also use PivNerd. Either one will work. Okay, now let's look at the temperature at point C. And we'll do it the same way we did the ones before. You can either use PivNerd or PV over T, pole vaulting over trees, either one. I think pole vaulting over trees works well. You can do point A, you can do either one. It doesn't really make a difference. I'll do it with point B and C. And we know that the pressure disappears because pressure is the same. So it's going to be VB over TB is equal to VC over TC, and I'm looking for TC. Well, I know that VB, I'm going to drop the times 10 to the negative 3rd because they're the same numbers. This is 4 divided by 3, and over here I have the volume at C, which is 4. The volume, I got something wrong. How about the volume at B is actually just 1. So I have 1 over 3 is equal to 4 over this value. So obviously TC has to be 12K. The other thing to realize is that this curve's an isothermal curve. So if that's 12, that's 12. Or even better, I knew that was 12 from the beginning, so I know this is 12. Oh my God, I love it when physics works. So now let's take a look at the work done from A to B, and also delta U from A to B. Let me do that, make that delta U from A to B. So let's go through each one of those. Well, first of all, the work done from A to B, well, work is equal to negative P delta V Hey, delta V is 0. That's 0. No work being done. So in this particular part, no work. No work. Yay, much rejoicing. Now, let's go delta U. And here's the important thing that's really, really helpful. Delta U is equal to 3/2 NR delta T. Well, I know those things, 3/2. N is 1 mole. R is 8.31. Delta T is 12 minus 3, 9K. So 3/2 times 8.31 times 9K. Well, 9 times 8 would be 72, maybe 75. 75 times 3/2. I can't do that. Let's try a calculator. Calculators are fun. They are my friend. 8.31 times 9 equals, dun 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 dun. Give me an error. Sorry this is taking so long. It shouldn't. Not real good with calculators. So 1.5 times 1 times 8.31 times 9 is equal to 112.185. So let's make it 112.8. And that's, of course, energy, so that is joules, which comes out of the K. I just didn't write it in there. So that gives me that. Here's the nice thing is, what that means is delta U is gone down, and it's final minus initial. So actually this is negative, so this should be negative. And delta U is equal to Q plus W. And since the work is equal to 0, then what that means is that Q, since W is equal to 0, Q is also negative 112.8. It's the same number. Beautiful. Okay, what I want you to do now is work your way the rest of the way around that PV diagram and figure out what's the work done in BC, what's the delta U for BC, what's the Q for BC. That's the next thing I want. So I want this. I want the work done from BC. I want the Q from BC. And I want the delta U for BC. So I want you to solve those. That's what I'm going to be looking for mañana. I hope this helped.